Hello everyone, today Teacher Sunny is here to talk to you about a problem that combines shaping. First, let me elaborate a bit, since many parents have been asking about this, so I'd like to explain it to everyone. In the study of mathematical thinking, actually, for this type of problem, at the elementary stage, what often happens is, in fact, you can solve most of these
Wow.
problems using two main ways of thinking. What are these two ways? The first is equivalent substitution. Equivalent substitution is actually the underlying logic of elimination. So, what is the second way of thinking? It's the thinking of quantity rate correspondence. Yes, the quantity rate route of thinking, because when we need to find a whole, that is, for one unit, it's the quantity divided by its corresponding rate, and then you can find the whole. So as long as you use these two ways of thinking, you can basically solve most of the problems. Oh, that's precisely why. When you were in second grade, you had already learned the fundamental concept of equivalent substitution with quantities in geometry. That's its underlying logical principle. These two distinct ways of thinking can both effectively solve elimination problems. All right, let's look at this problem. If A increases by 13, it becomes equal to B. If B increases by 37, it is exactly 6 times A. Find the values of A and B. You can draw line segments, but Teacher Sunny rarely draws line segments because for complex figures, drawing line segments isn't easy. However, if you can make the line segments clear, if you can draw it out well, then solving the problem will yield twice the result with half the effort because it's intuitive. But in complex problems, drawing the diagram well, especially line segment diagrams, is not easy. Alright, let's take a closer look. Of course, we can also utilize shape diagrams. Previously, Teacher Sunny specifically mentioned drawing diagrams for key points, right? So, if it's exactly 6 times a particular value, we can certainly figure it out, right? We can solve the problem effectively according to this multiple, can't we? Today though, Teacher Sunny will demonstrate another method. Basically, the underlying concept is precisely the same. It's just a slightly different form. Oh, so we'll still use this shape. Let's use the diagram to solve the problem. First of all, A increases by 13 to be as big as B. So first, we need to figure out which one is bigger and which one is smaller. Obviously, B is less than BA. Wait, that's not right. Clearly, A is less than B, A is less than B, because A needs to increase by 13. Will only be as big as B after that. So it's clear that B must be greater than A. Conversely, A must be less than B, so we should definitely start from the smaller part. Now, if we take and represent the number that it stands for, let's use a triangle instead. So what about B? If you add 13 to A, it will be as big as B, right? So we can conclude this. This is the first thing we need to figure out. Alright, this comes from the information given in the problem. So what's the second piece of information? After increasing log B by 37, it becomes exactly 6 times A. Okay, so we know this is B, right? So if B, then we can conclude is increased by 37. What does it become? It becomes exactly 6 times. Here, this is right? So it's exactly 6 times A. Okay, well, I think that sounds good to me. To effectively balance both sides, we will carefully remove one triangle from each side. That is to say, we are performing a symmetrical operation. 51 long years and exactly 5 distinct triangles. So it's very clear that one triangle equals 50 divided by 5, which is 10. Alright, so now we can solve for, because this is also, since AA represents one triangle. Okay, once we found A, finding B becomes easy because B is equal to one triangle plus 13. Alright, so one triangle is 10 plus 13, so B equals 23. Have you learned it? If you have, please give Teacher Sunny a like and follow and share this with more people so we can all learn together.